This video we're going to look at the neurotransmitters that are used by the autonomic nervous system. And whenever you learn about neurotransmitters, you also learn about the receptors that the neurotransmitters bind to. So you'll see on this slide we're comparing sympathetic versus parasympathetic. We've previously mentioned that the autonomic nervous system uses two motor neurons. So again, we have preganglionic and postganglionic up here using the sympathetic, and the same down here we have a pre and postganglionic neuron. Notice the effector cell. This effector cell could be the exact same cell. This cell could be the same effector organ. It could be a heart. And we've got sympathetic neurons going to it and parasympathetic neurons going to it. So when we look at neurons, one way to classify a neuron is based on what neurotransmitter it releases. So we're looking at basically two neurotransmitters, acetylcholine and norepinephrine. And if you're a neuron and you release acetylcholine, we call you a cholinergic neuron. If you're a neuron and you release norepinephrine, we call you an adrenergic neuron. So this is terminology we use. So you'll notice with the sympathetic division, the preganglionic neuron is cholinergic because it's releasing this acetylcholine. The postganglionic neuron is adrenergic because it's releasing norepinephrine. Now the receptors have to recognize those neurotransmitters. And we're going to learn a little bit about some of the types of receptors, but one type of acetylcholine receptor is called nicotinic receptors. And then the receptor for norepinephrine is called adrenergic receptors. There's an additional acetylcholine receptor called muscarinic, which we'll talk about, which you can see down here. Muscarinic receptors, which would be on this cell. Nicotinic receptors, which could be on this neuron. So let's just quickly review. If you're a sympathetic pathway, you use acetylcholine, therefore you're a cholinergic, and norepinephrine, therefore you are an adrenergic. If we look down here, parasympathetic, you both pre and postganglionic neurons use acetylcholine, so they're both considered cholinergic. So again, kind of a review. Cholinergic neurons release acetylcholine. All preganglionic neurons release acetylcholine. So if you were to look back on the previous slide or just look down here, here's a preganglionic neuron. Here's a preganglionic neuron. They're both releasing acetylcholine, so they're cholinergic. All parasympathetic neurons use acetylcholine, whether you're pre or post. So again, this panel C here is parasympathetic. That postganglionic neuron is releasing acetylcholine. So if you're parasympathetic, the only neurotransmitter you use is acetylcholine. There's a few that don't, like the ones going to sweat glands. Or I should say a few sympathetic postganglionic neurons are cholinergic. If you recall, a sweat gland responds to acetylcholine. Okay, let's look at the receptors. Again, in order to respond to a neurotransmitter, you must have the receptor. So we have cholinergic receptors, and they can either be classified as nicotinic or muscarinic. And how these receptors were identified is that nicotinic receptors actually will also respond to nicotine, and muscarinic receptors will actually respond to a molecule found in a specific type of mushroom, and that molecule is called muscarine. So that's just how they have classified these. So a lot of times nicotine will stimulate nicotinic receptors in the body, and this molecule in or it's a toxin in poisonous mushrooms stimulate muscarinic receptors. Okay, let's look at adrenergic neurons. So who are the adrenergic neurons? The postganglionic sympathetic neurons only. So that's right here. That's a postganglionic neuron of the sympathetic division releasing norepinephrine. The receptors that recognize norepinephrine are classified as betas and alphas. So you're going to be seeing a lot of this. Alpha 1 is a type of receptor, beta 1 is a type of receptor, alpha 2 is a type of receptor, beta 2 is a type of receptor. They all respond to norepinephrine. Some of them produce excitation of the organ, some inhibit the organ. It all depends on what organ has those receptors. Okay, so the next big thing is to talk about, okay, what's the responses? What are the autonomic responses? Let's start kind of general. Let's remember that the sympathetic responses are kind of your alarming, fight or flight, stress responses. So you can think of the sympathetic division as we want to promote alertness. We want to increase energy. We want to increase our heart rate and our respiratory rate. We want to increase our skeletal muscle activity. And we want to mobilize more energy reserves. So some examples. We dilate our pupils. Why? Take in more of our environment. If we dilate our pupils, we can see more of our environment. So that's a kind of a fight or flight response. We increase our heart rate. We increase the force of our heart contractions. And we increase our BP, or blood pressure. Why? That's all going to pump more blood to our skeletal muscles, so we have more energy, more oxygen going to our skeletal muscles, so we can help deal with that stressful situation. We decrease blood flow to what we deem as non-essential during times of stress. So an example of a non-essential organ, something you don't really want to worry about when you're in a stressful situation, is your stomach. There's no need to digest food when we're under a stress. So we'll shift blood flow from our GI tract to more important things like our skeletal muscles and our heart. Our airways will dilate. Again, we need more oxygen. We need more oxygen and we need more energy reserves like glucose or fat. Our respiratory rate increases. Again, all because we need to make more ATP, more energy to deal with the stress. So we release stored energy sources into the blood, so we'll break down fat to release fatty acids for energy. These responses tend to be a little longer lasting, or they linger around a little bit. So if you ever go for a jog or exercise and then go sit on the sofa, your heart's still going to beat pretty fast. You're still going to be breathing pretty heavily after you exercise. That's because epinephrine and norepinephrine are still floating around in your bloodstream. You can't get rid of them very quickly. So you're not going to exercise and immediately you step off the treadmill and your heart rate slows right down and your respiratory rate slows right down. It's going to take a little while because of those hormones, epinephrine and norepinephrine, or adrenaline, still lingering around in your bloodstream. Parasympathetic responses normally dominate, meaning we're more often in our parasympathetic mode, if you will. Some of the typical responses: salivation, so our salivary glands are stimulated by parasympathetic. Lacrimation, which is tear production. Urination, digestion, defecation are all parasympathetic responses. Or the 3 Ds: decreasing heart rate, decreasing diameter of the airways, so you don't need as much oxygen when you're resting, and decreasing the diameter of the pupil. You don't have to take in as much of your environment when you're resting. There's an interesting phenomenon called paradoxical fear. A paradox is something that is kind of the opposite to what logically what you would think would occur. So paradoxical fear is when you're so scared and you feel there's no escape. So a lot of times people who are in, some extreme near-death experience, the body enters what's called paradoxical fear. Now you would think that would be such a massive stress on the body that you would massively overactivate your sympathetic responses. But indeed the opposite happens. That's why it's called paradoxical fear. So what happens is you get a massive parasympathetic activation, and this causes the loss of control, and you urinate and possibly defecate yourself. Now, I've never had a student do this over an exam, but I'm still waiting for the day that my A&P exams are so scary that a student enters paradoxical fear. Actually, I really hope it never happens. Another thing that's associated with your autonomic nervous system is our polygraph tests. So polygraph tests are based on alterations of autonomic responses due to the limbic system. So remember, your limbic system are emotions, and a typical person has emotions, and those emotions alter some of your autonomic responses. There's always a few people that don't have this link. They're emotionless over stressful situations, and that's why polygraph tests are not admissible in court, because there are people that lack the emotion when they're under these stressful questions, and they don't get the same responses. So for example, dilation of blood vessels. So people undergoing a polygraph test will become a little red, and that can be measured. Their pupils constrict because of the limbic system influence. Heart rate increases, breathing rate increases, blood pressure increases. So this is all what the polygraph is based on, is your autonomic responses, but it's your emotions that are influencing the responses. So this is kind of a subjective test, and that's why it's not admissible, because people can lie without the emotions. Alright, the next video, so this was video 3. Video 4 is going to go over all these little more specific responses. And this video number 4 is going to be the most important video, because we're going to be talking about this stuff again in A&P2 when we talk more about some of these organs. Right? A&P1, we haven't really discussed our visceral organs. We haven't learned about the heart. We haven't learned about the liver. We haven't learned about the pancreas, the GI tract. So a lot of this stuff is going to be a little tricky for us now because we haven't learned those organs, but it's going to be very useful for us when we enter A&P2. I always know what students didn't have a very good background in the autonomic nervous system when we get to A&P2, because I start talking about how the heart's regulated, sympathetic, parasympathetic, and I can always tell what students didn't have me, because if you have me, you'll make sure you know your autonomic responses. So we'll do that on video number 4.